Hello all, welcome to the video lecture. This is Ramesh Lama. In this video, we will be discussing about the image classification. Well, understanding the contents of image or image region is one of the core problems for computer vision, which is fundamental to image and scene understanding. In image classification, the goal is to assign input image a label from some predefined set of categories. That means when you are doing some image classification, your system receives some input image, which is this cute dog, and in the example, and the system is aware about the predetermined set of categories or labels, which may be dog, cat, buffalo, or plane. And the job of the computer is to look at the picture and assign it one of these category label. Here we can see the computer receives this picture and it will assign the its category or its label, which is dog. And basically the image classification, before we perform any classification, it goes through different steps. And first is the sensing, which is like we have to which deals with the acquisition of images. And next we go through the pre-processing, which is the filtering, noise reduction, and image enhancement. And another one is the feature extraction. Here in computer vision, a feature is a measurable piece of data in our image which is unique to this specific object, and it may be distinct color in image or a specific shape such as line, edge, corner, or an image segment. And the feature provides rich information on the image content, and they correspond to local region in image and are fundamental in many applications in image analysis, recognition, matching, and the reconstruction. So basically the feature extraction consists two steps. One is the feature detection, which is finding features such as edges or corners, and another is the feature description, which is to assign the quantitative attributes to detected features such as feature location, orientation with respect to the other features. And for the if you are more interested in feature detection and description, you can find these videos in these following URLs, which I have made for the previous semester. And you can find different like the use of feature and what are the good features, and other matching problems such as shift and the feature like here you can find the videos for feature detection and description in more detail. And let's come back to our classification. As I have said before, like the classification deals with the class labels to an to input image, or we assign the class level to the input image patterns. And for that we use the set of features, or based on the set of features we assign class label to the unknown input pattern. And classification can be thought of as two separate problems. One is the binary classification and another one is the multi-class classification. In binary classification, only two classes are involved, and whereas in multi-class classification, it involves assigning an object a set like object to several classes. Here we can see an example of binary classification problem might be determining whether the given image contains buffalo or not, which we can see on the left side, and it gives us the answer to a question. Like the answer will be either yes or no. For yes it will be 1, or for no it will be 0. And in while the example of multi-class problem, it might be determining the different type of animals. Supposedly, out of the several like hundreds possible types we can see here, like for the given image on the right side, it can be the image of cat, dog, tiger, or lion, and it comes like the answer can be more than one. Like the label, it consists of label which is more than 2. While observing these problems, like it seems like classification is a really easy problem, because like in human brain, so much of our visual system in our human brain is hardwired to this sort of visual recognition task. However, for machine, it is not that easy as we think. When we look at the picture, we can immediately identify its dog. Things would have got millions of years worth of evolutionary context to have immediately understand and what is this. But the computer doesn't have that advantage. For computer, this looks just a massive array of integer values, which is like this intensity, which ranges in the which represent the intensity across the whole spectrum, and it's very difficult to understand this image for the computer. And this problem we refer to as a semantic gap, and the idea of dog is a semantic label that we are assigning to this image, and there is a huge gap between the semantic idea of dog and these pixels values that the computer is actually seeing. And in order to reduce this gap, one straightforward solution is to detect the edges, which we have discussed in our previous class. And because we know that edges are pretty important when it comes to the visual recognition, so one thing we might try to do is compute edges of the given image, and then we categorize all the different corners and boundaries and write explicit set of rules for recognizing different part of cat, and finally classify it as cat. However, it turns out not to work very well, because it's very hard and it may not work for another image. For example, if we have image of car, we have to write another set of rules and we need to start all over again. So it's not the scalable approach. So we have to come up with some algorithm or method for recognition task which scales much more naturally to all variety of objects in the world. So this is the idea of data-driven approach. And rather than sitting down and writing the hard hand-specified rules to try to craft exactly what is cat or what car or bus, we will collect large set of many cats and many dogs or many cars and different things like this object of the different categories, and then we train the machine learning classifier. That is, like we collect the data set of images and labels, and we use the machine learning to train the classifier, and we evaluate the classifier with the new objects with the no labels. Here we can see, like we collect the we can see here the example of training set. It consists of the lots of images of aeroplane and automobile, bird, cat and deer. And what we do is we use these training images and its label. We use machine learning to train the classifier, and after we train, we will evaluate the classifier with the new image with the no labels. So that is the classifier will take all the data and summarize it in some way, and then it will spit out the model that summarize the knowledge of how to recognize these different object categories. So we can see here we have got the data set, and we have that data set we divide into training set and the test set, and from this training set we will extract the features, and we have got the label as well, and we will use this to train the classifier, and this classifier will give us the we will get the after that we will have model, and then with this model we will apply the new image, that is the test set, and that will be able to recognize the cat, dog, and so on. And here we can see that the classifier will have two functions, one is called the train, and another one is the test. In case of train, it is going to take input images and labels, and then it will output the model. And the next is the predict, where it will take the model and make predictions for the image. And this idea of data-driven classifier is so general that it fits on the simple classifier to the very complex deep learning approaches. And in subsequent classes we'll start with the very simple classifier, and then we'll proceed to the more complex approaches such as deep learning classifiers.